Welcome. This is the 2008 quantitative section from your practice exam that y'all did from 2000. This was the most missed section, quantitative. My suggestion for you, you don't actually have these in a document anywhere, so I would pause the screencast and try the math problem all by yourself first, and resume the screencast to see if you can check yourself to see how you did. So don't just watch the screencast. Be an active participant and actually give it a shot on your own first. So the first one in 2007, in the U.S., there were approximately 480 cars for every 1,000 people. The total number of cars in the U.S. in 2007 was closest to what number? Well, right away, what it means is that is a card or a little nugget, like when we did our coconut math. So 480 cars for every 1,000 people. Well, the question is asking me, what was the total number of cars? So cars is a unit that needs to be left on top. Well, this question is also assuming that you know at least generally the population size of the States, and it's about 324 million, but we're going to go ahead and round down because it's easier numbers that way. So that's how many people are currently in the United States. People cancels, and I'm also going to cancel out 3 zeros here, 3 zeros. And I'm just going to multiply 48 times 3 really quick, and 8 times 3 is 24, 4 times 3 is 12, 13, 14. Go back here, and I'm going to add my 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 6 zeros. That's how many cars. And that number, 144 million, is closest to C. So that is my answer. Number 27. If a country has a crude birth rate of 24 per 1,000, because that's the definition of a birth rate, they do it per 1,000 instead of per 100. So that's important, the fact that it's per 1,000. And a crude death rate is 8 per 1,000. Sometimes you'll also see them give you the immigration and the emigration, or they go ahead and combine that into a net migration. So if it's a positive, so if you have more coming in than immigrants leaving, you're going to have a positive net migration. So the formula, when you see a growth rate or the population growth change, it's going to be births plus immigration in minus death plus immigration out. And in this situation, either of these, so we just assume those are 0, which is why you have 24 minus 8, which gives you 16. Now this was per 1,000, and the question is percent. Percent has to be in per 100. Have to move the decimal. So we have to get rid of one of the decimal zeros and move the decimal over 1. So instead of 16, you have 1.6, which is letter B. Okay, so for questions 42, they give you a graph. So the first thing you want to do is kind of get familiar and familiarize yourself with what the graph is actually telling you. So in 1997, the World Resources Institute estimated the world's proven oil reserves to be 1,000 billion. Ultimately, recoverable reserves is 2,000 billion barrels. So in other words, since this is actually recoverable, this is useless information right there. The table below shows the world consumption of oil between 1986 and 1997. So looking down here, I see 1986 and 1997, so my years are on the left column, but what they're giving us is in million barrels per day. So that kind of jumps out at me. We're talking million, 10 to the 6th, and we're talking per day, so that's important too. If you look down here, it says at the 1997 rate of consumption, about how long will the estimated 2,000 billion oil last? So at 1997 rate of consumption, the 1997 rate of consumption is 74. And go back up here so you can see this car is going to be 74, and according to this up here, million per day. So 74 times 10 to the 6th million. That's barrels in 1 day. That's just a nugget right there. That's a car. Okay, I'm going to keep reading down here. So it's the estimated 2,000 billion barrels of oil. How long will this many barrels last? So top, how long is what the question is asking me. I need time to be on top. Now, the information I was given was in day. And look over here at your answer choices. It's in years. So I know automatically that this day has to be converted to years. So I know that there are 365 days in 1 year. Okay, and then the other card, I have 2,000 barrels. So I have 2,000 billion barrels. So I'm just going ahead and write. Let's go ahead and we know billion is times 10 to the ninth. And I know that's 9, and then 10, 11, 12. Let's go ahead and make that simple and say 2 times 10 to the 12 barrels over 1. There's a card. So I'm looking at this card as it compares to this card up here. And notice that barrels is both on top. That would be a barrel squared. And I also noticed that my years is on the bottom. No bueno, because I need time to be on top. So I'm going to take this card up here, this whole section, and I'm going to flip. Remember in coconut math how we just flipped it if the desired unit was not bottom. Okay, so I want barrels on bottom right here so they'll cancel out. So I'm going to put 70 times 10 to the 6th barrels down here over 1 day. I know that there are 365 days in 1 year. And so let's see if my unit will give me just years. Days, days, barrels, barrels. Woohoo! Left with just years. Shape here. And then I can go ahead and knock out this times 10 to the 6th. That's a bunch of zeros. It's just like knocking out 0 on top of a 0. And I'm going to get 6 here, which turns this into 10 to the 6th up here. Okay, now, so the first thing you're going to do whenever you're doing dimension analysis or fractions, you multiply everything together that's in the denominator, you multiply everything together that's in the numerator, and you're going to divide the by the denominator. Well, up here, it's 1 times 1. So really, I have 2 times 10 to the 6th on top. And then on the bottom, I have 74 times 365. So real quick, let me do that awesome multiplication. 365 times 74. 5 times 4 is 20. 6 times 4 is 24, 25, 26. 3 times 4 is 12, 13, 14. 7 times 5, 35. 7 times 6, 42, 45. That makes 45. 7 times 3 is 20. Plus 4 makes 25. So I'm going to add this up. 0, 6 plus 5 is 11. 5, that's 9, 10. 5, 6, 7. And now I'm left with the numerator is 27 and 10. So technically I'm supposed to divide this into this over here, to this number. But let's go ahead and make our lives a little bit easier. Let's make this a 0, say. So if we go ahead and by the way, always, 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 simplify, round, use as round as numbers as possible. But that's the same as 2.7 times 10 to the, let's see our decimals right here, 1, 2, 3, 4. 4th power times 10 to the 4th power. Okay? So all of this big old chunk up here now equals, and if this was an FRQ, then they want to show your math, show your actual calculations on the lines. Now this is obviously not an FRQ, this is a multiple choice, so you'll be doodling probably all over your book, but that's totally fine. Okay, so this division, you kind of can separate out the exponent over here, 2 separate problems. So my final answer for that one, I know it's going to be 2 divided by 7, whatever that is, times 10 to the, whenever you're dividing exponents, you subtract 10 to the 2. But let's figure out what the front portion is going to be. So when you're dividing, doing long division, and you're doing a decimal into something, it's always easier to go ahead and move your decimal back over. So that is the same thing, because of equalities, this is the same thing as 27 into 20. Okay, I already tell you off the bat, 27 is not going to go into 20 without a fight. So we need a decimal and a 0. Okay, so how many times does 27 go into 200? Well, if you think about it, 30 goes into 100 about 3 times, and there's 2 of these, so it's about 6. Another one, since there's some left over. So let's start off with 7. And let's see if I'm right. 7 times 7 is 49. 7 times 2 is 14. Add 4 to that, that's 18. So 200 minus 189 is 11. Okay, another 0. Bring that down. Bring that 0 down. So 27 goes into 110. So let's think about that. 27. So 30 goes into 100 about 3 times, and then that gives you just about a right extra for you to get that 4th one. 7 times 4. 7 times 4. You know what's awesome about this? is that you can stop if you want to stop. That's 28, but you don't need to know that. You only need 2 decimal places in this scenario because I'm looking over here at the answers. Sometimes you want to take it to do your third one just in case this number rounds, but in this scenario it doesn't. So 0.74 times 10 to the 2 is the same thing because 10 to the 2 is 74. And the closest one to that is 75 years. Okay, so for 42, you're still using the graph from previous, but it's asking you what is the approximate percent increase in consumption from 1986 to 1997. So percent increase on consumption, there's a formula we use for that. It's the absolute value, old minus new, divided by old, times 100. Or you can do new minus old. Doesn't matter because it's absolute. Or some people just say it is the change, whatever the change is between the two, times 100. So look on the chart. In 1986, the old, that's the older year, so that's the old, is the new is 74. So 62 minus 74 divided by 62. Okay, and I know I told some of you that this was going to be, don't worry, it'll always be a nice one when you're doing the AP people. They won't do that to you. I lied. Okay, so really here, 12 divided by 62. And to simplify that, you can't divide this by 2, same thing as 6 divided by 31. So we got 31 into 6. All right, so 31 goes into 6, nada. So we're going to go ahead and put our decimal there. How many times does 31 go into 60? Well, it's not 2 times because that would be 62. It's 1 time. So that's 60 minus 31. Okay, so we know 10 minus 1 is 9, and then 5 carry that over, so we're left with 29. And then let's add one more 0 here, and go ahead and bring our 0 down. So 31 goes into 290, a lot, because we know it's at least 3, 3, and almost 3. That's about 3, 6, 9. About 9 times. See if it works. 9 times 1 is 9. 9 times 3 is 27. And that's pretty much good to go. I can't get another one on there. So don't forget to now have to multiply that times 100. And so you're pretty close. That's 19%. And what's the closest to 19% over here in our answer choices? That would be B. Woo! Okay, number 44, actually, it is a graph, so, and it's got numbers on it. Think in exponents and what these mean, but honestly, it's more of, do you understand the concept of island biogeography? It says here, 5 islands, A, B, C, D, and E, differ only in distance from the mainland area and species diversity. Which island would be predicted to have the highest diversity? Well, the theory of island biogeography says that the island that is the largest and closest to the mainland should have the most biodiversity because you have a lot more opportunity for immigration and emigration. And if something were extinct, it's okay because like another bird could fly over pretty because it's not an isolated small island far, far, far away. So we know that the closest and the biggest. Well, if I look down at my answer choices here, the distance are going to be A and B because they're both 50. Now, out of these two choices, which is the biggest? So I look over here, and 10 to the 6th is much larger than 10 to the 2, so I know B is my answer. So not actually that one, it's more conceptual. For number 77, it's a doubling time problem. What is the population doubling time in years for a country with an annual growth rate of 3.5%? So the equation for doubling time we know is 70 divided by the growth rate. And the growth rate here is 3.5. Now, doing demographics like this, we're not moving the decimal over at all. And if you want to process this 700 divided by 35, looking over at the answer choices, it's pretty clear that 70 times 70 by 3.5, that your answer is 20. So this one really just had to know the equation for doubling time because this one's pretty simple. Now the next one. So when you're thinking about half-life problems, the definition, first of all, of half-life is the time it takes for a sample to decay into half of its daughter isotope. So if this sample here, they're saying has a half-life of 4 days for it to decay into half of its sample, or half of the sample to decay. 4 weeks after the introduction of radon into a sample, the fraction of the original amount remaining is closest to what? Well, the half-life was given to us in days, not weeks. So just a quick little aside over here. 4 days, and how many days are in 1 week? So you that. So 7 days in 1 week. Or, oopsie, sorry. 4 weeks, JK, 1 week, 7 days. And you didn't really have to do a dimension analysis for that. I just did it just so y'all can see me mess up, but just kidding. Right? So we know that this sample, they're talking about 28 days. What happens to, what is the ratio of the original sample for 28 days? Well, day 0 to day 4, and by the way, there's a couple ways to kind of write it all the way out for you so you can kind of get that visualization of how half-life. So after 4 days, we know that only half of the sample is left. Half of the sample is left, and we have, so 4 more days gives us 8 days. Because every 4 days, that whatever's left in the sample is going to decay. So now after 4 days, another half has of the original sample now. Another half has passed after 16 days. After 20 days, another half. Another half. And then 28 is another half. Okay, so essentially really what you have is 1, 2, 3, 4, 5, 6, 7. You have 7 half-lives have gone by in that 4-week time period. So that's also the same thing as 1/2 to the 7th power. So really what you're doing is you are multiplying 2 times 2, like a half times a half times a half times a half. So let's go ahead and multiply our 2 times 2. So, this is going to end up being 1 over, see, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And then 64 times 2 is 28. Okay, so after, so notice how I went all the way down here, and that's 7 times. So my fraction remaining is 1/128th of the sample. E. 98. Ooh, what do you know it? It's an energy question, and I bet you money you'll get an energy question on your multiple choice part, and they're going to ask it to you in watts and want you to convert it to kilograms. And they're probably going to ask you it, give it to you in days, and ask you about in years. Sometimes they actually do it by week, but they will want you to convert 2 things. They're going to want you to convert. They're going to want you to convert days. So a home uses 10 100-watt light bulbs for 5 hours per day. Approximately how many kilowatt hours of electrical energy, are consumed in 1 year using bulbs? So what has to be on top? Years. What do they give it to me in? Days. So let's figure this out. So my first card, by the way, is 10, because this is a little, they threw you a little loop here by telling you there's actually 10 of them. So 10 over 1, there are 10 of these. And my real bridge kind of starts here. I am going to have 100 watt light bulbs on for 5 hours per day. And how many kilowatt of electrical energy? So once in kilowatts, well, there are 1,000 watts in 1 kilowatt. And they want it in years, not day. So I need to convert 365 days in 1 year. Okay, so let's see what happens to my units here. My watts cancels, my days cancels, and I am left with kilowatt. So really it's going to be kilowatt hours per year. So I'm good to go on that. And the other beauty here, 3 zeros here. By the way, I always simplify before I start my math. So I'm getting here, and 1, 2, boom, 3. So essentially, on top is 1 times times 365 times 5. And then you're dividing it by 1. So really, I just need 365 times 5. 5 times 65. 6 times 5 is 30, plus 2 is 32. 15, 16, 17, 18. So this is how many kilowatt hours per year. And look at that. Now that's it. That's all of them. So make sure you've stopped it and tried it on your own before you actually look at all of the answers. And be aware, obviously, there are multiple ways to do these problems. And if you'd rather just do it in your head, that's multiple choice. But when you do dimension analysis, it's nice because you get to cross out your units and verify that you're actually doing it the right way. Good luck!